Hello everyone. Today our chapter is Acids, Bases and Salts, Part 2, which is the continuation of Part 1. In this, we are going to know about chemical properties of acids, chemical properties of bases, acids or bases in water solution, reaction between acids and bases, effect of dilution on an acid or a base. Okay. First, we'll know about chemical properties of acids. Okay, and this reaction with metals, that is acids, how it will react with metals. Okay, acids like dilute hydrochloric acid, dilute sulfuric acid react with certain active metals like zinc and iron or etc. What? To form salt, and there is an evolution of hydrogen gas. Thus, these acids or substances containing these kinds of acids should not be kept in metal containers. Okay, here is a general representation of the reaction happening. See, metal plus dilute acid gives salt plus hydrogen gas. Example, zinc plus sulfuric acid gives zinc sulfate and hydrogen gas is evolved. Okay, next we'll go to reaction with metal carbonate and hydrogen carbonate. See, limestone, chalk and marble are different forms of calcium carbonate. Okay, acids react with metal carbonates and hydrogen carbonates or bicarbonates to produce what? Corresponding salt and carbon dioxide gas and water. See how the reaction happens is metal carbonate reacts with acid and there is a formation of salt, carbon dioxide and water. The products are what? Salt, carbon dioxide and water. Okay. There is an example, calcium carbonate plus hydrochloric acid gives calcium chloride, water and carbon dioxide. See, calcium chloride is a salt. Calcium carbonate is a metal carbonate. So, the reactant is calcium chloride, water and carbon dioxide. Okay. Next, we will know about, see, the carbon dioxide is evolved, I told in the previous slide. Yes, there should be some test to identify whether carbon dioxide is evolved or not. Yes, the carbon dioxide gas is released with a brisk effervescence. You can see a slight effervescence in the test tube. Okay. Now, there is a test for carbon dioxide. When carbon dioxide gas is passed through the lime water, that lime water turns milky due to the formation of white precipitate of calcium carbonate. Okay, the lime water will turn milky. Okay. Next, but if carbon dioxide is passed in excess, what happens? Milkiness disappears due to the formation of what? Calcium bicarbonate, which is soluble in water. See, you can see here are the equations. That is lime water reacted with carbon dioxide. You get calcium carbonate, which is white precipitate, and you get water. And this calcium carbonate is reacted with water to get carbon dioxide and calcium bicarbonate. Okay. Next. Now, reaction with metal oxides. Okay, acids, how it will react with metal oxides. Acids react with certain metal oxides to form salt and water. See, these metal oxides are being basic in nature. They are also called as metal oxides. Now, metal oxide plus acid gives salt and water. Here is an example, that is copper oxide, hydrochloric acid gives copper chloride and water. Okay. See, here is a picture. You can see copper oxide, hydrochloric acid. You are getting copper chloride and water. Okay. Chemical properties of bases. Here, reaction with metals, that is how bases reacts with metals. Okay. Strong bases react with active metals to produce hydrogen gas. Okay, that is metal plus base, you get salt plus hydrogen gas. Thus, these bases should not be kept in metal container. Okay. Here is an example, that is zinc plus NaOH you get sodium zincate and hydrogen is evolved. Okay. Hydrogen and sodium zincate are the product. Okay. Next, reaction with non-metallic oxides. Bases react with non-metallic oxides to produce salt and water. Okay. This reaction proves that non-metallic oxides acidic in nature. These are acidic in nature with non-metallic oxides. See, base plus non-metallic oxide, you get salt and water. Here is a carbon dioxide and calcium hydroxide. You get calcium carbonate and water. Okay. Here you have got the salt and water as a product. Okay. This is how the reaction with non-metallic oxide will happen. Okay. Next, acids, bases in water solution. What happens when acid or bases in water solution? In presence of water, acids give H plus ion. Okay, which cannot exist alone. That H plus ion cannot exist alone. So it combines with molecules of water and they form H3O plus. That is also known as hydronium ion. So we can say in presence of water, H plus ion or H3O plus ion, that is hydronium ion. In the same way, in presence of water, bases give what? OH minus ion. Okay. Here is an example. If you take hydrochloric acid plus water gives hydronium ion and chloride minus. Okay. Then H plus H2O gives H3O plus, that is also hydronium ion. Then if you take a base like sodium hydroxide in water, you get Na and OH minus. See, when base is taken, OH minus is given out. Okay. Next, reaction between acids and bases. Okay, what happens when acids and bases react together? We'll see now here. Acids react with bases to produce what? Salt and water. In this reaction, an acid neutralizes the base. See, acid will try to reduce the effect of base, or vice versa can also happen. Okay. Then, so this reaction is known as neutralization reaction. Why? Because either acid reduces the effect of base or base reduces the effect of acid. So, this reaction is known as neutralization reaction. In general, neutralization reaction can be written as base plus acid, you get salt and water. Okay, here is a general equation, that is H into X plus M, you get Mx and HOH. Okay, here H represents the hydrogen atom and M represents the metal atom. Okay. Next, H plus OH minus gives H2O. Okay, H plus OH. There is 2H combines to form H2 and 1 O. So, there is a H2O formation. And there is an example, if you take here sodium hydroxide, which is a base, and hydrochloric acid, that is acid. That gives NaCl, that is sodium chloride, which is a salt, and H2O is the water. So, this is the perfect example of acid plus base giving you salt and water. Okay. Next, effect of dilution on an acid or a base. See, dilution is nothing but mixing of an acid or a base with water. You are just putting a water either to an acid or a base. That process is known as dilution. Okay. It results in a decrease in the concentration of the ions per unit volume, and the acid or a base is said to be diluted. So, the concentration of the acid or the base is decreased. Okay. When acid or base is added to a water, their molecules dissociate to form ions. That is, they are breaking to form ions. Here is an example. If you take HCl plus H2O gives H3O plus Cl. And if you take water, H2O plus H what happens? You get hydronium ion. And if you take base, that is NaOH, you get Na plus and OH minus. Okay, base when react with water, you get OH minus itself. Okay. Then dissolving an acid or a base in a water is highly exothermic. What is exothermic? Heat is generating. Okay, so care must be taken while doing it. The acids must always be added slowly to water with constant stirring. See, you should be stirring one side and you should be adding water. So you have to be careful because this is an exothermic, so heat is generating. Okay. Then water should not be added to concentrated acid. Water should not be added to a concentrated acid, because if water is added, the heat generated may cause the mixture of splash out, and it also may cause burns. So we should be very careful while adding water to the acid or concentrated acid. Okay.